To generate DTO classes, quite a few options exist. Most of the current ones rely on there being some sort of specification available that describes the API. An often used format for that is OpenAPI, also known as Swagger. In other words, once an API has support for Swagger, or any other OpenAPI implementing framework, which most of them do as it quickly became the de facto standard, we can generate client-side DTO classes or even full clients with calls to all resources on the API. And there's a few options available. One is Swagger CodeGen. You can find that at the link on screen, but it's Java-based, so you do need to have the Java runtime installed on your machine. If you don't want to do that, which I totally understand, there's an online version available as well. Another option is NSwag Studio. NSwag is much like Swagger. It's an implementation of OpenAPI you can use in your API projects to generate documentation. NSwag Studio is a Windows application that generates DTOs and potentially clients from an OpenAPI specification. And then there's the elusive Add REST API client option in the right-click menu in Visual Studio. That's been there for quite some time. But it's currently not nicely integrated with Visual Studio when using .NET Core projects. It should be coming soon though, as the library that's used for this behind the scenes does already support .NET Core. And that one is called AutoRest. You can also use it from the command line, which means you don't need Visual Studio to generate code, and it also starts from an OpenAPI specification. So all of these options will work, but which one should we choose? Well, they all generate code a bit differently. And AutoRest even adds a using statement to Microsoft.REST to the DTO classes. Not something I'm particularly fond of. But in the end, with minimal after-generation editing, you'll end up with good DTOs with each of these options. Personally, I prefer NSwag Studio, as it offers a huge range of possible customization. Let's check that out in a demo. In this demo, we'll use NSwag Studio to generate DTOs for our client. Let's install NSwag Studio first. We're looking at the NSwag Studio link at GitHub. Here you can download the MSI installer and install it. I already did that on my machine, so let's launch it. On the left, we can define things having to do with input. That would be our Swagger definition file. On the right, we have a lot of options for output. Let's start with input. We can generate DTOs from an assembly, from a JSON schema, from ASP.NET Core API Explorer, and so on. In our case, we're mimicking an API of which we don't know what it was built in. So all we have is that Swagger file. Let's have a look at our API again. So let's start it up. This small link here on top, well, that's the location of the swagger.json file. So let's add that to the root. And there we go. It's this Swagger file that Swagger UI uses to generate the documentation pages we were just looking at. Let's copy-paste this URI. And there we go. That's all as far as input is concerned. On to output. We want to generate C# classes, so we check C# client. That adds an extra tab. Let's open it. And let's input a namespace for our DTO models. Movies.client.models sounds like a good value for that. It implies we're generating models, DTOs in our case, for use by our Movies client app. We only want to generate DTO classes, and Swag Studio can potentially generate more. It can also generate a client to integrate with an API. But using those implementations means we're hiding a lot of the details we want to learn about. Moreover, they don't really follow best practices and tend to go for a simplified approach. So I prefer not to use them. Let's uncheck that. There's a lot of options we can choose here, but most of them are not needed for our purposes. Personally, I prefer DTO classes to be as plain and simple as possible, as they only serve one purpose. They're there for transferring data across the wire. So let me uncheck all of these options that would result in additional classes or annotations being generated. Depending on your architecture, for example, when you reuse those DTO classes for other purposes, your requirements may vary. The nice thing is that NSWAG Studio will almost certainly serve your needs. One thing that is important to look into is the class style we want to generate. The default is INPC, which stands for iNotify Property Changed. Choosing this will generate DTOs that raise property change notification events, which come in handy when creating a Xamarin app. For our purposes, however, POCO or plain old CLR objects are sufficient. So let's select POCO. One more thing to change. Let's scroll down a bit again. The default type for datetime is set to datetime. Yet the preferred type these days is system.datetimeOffset, as next to all the functionality from a datetime, it also includes time zone awareness. So let's change that. And that's it. Let's click Generate Outputs. And let's have a look at our classes. We've got our movie class here, a movie for creation class, a movie for update class, and so on. Exactly as we saw when we looked at the Swagger documentation. If you're not okay with how these look, it's just a matter of changing an option on the settings screen and generating output again. I'm quite happy with how they look, but there's one class that's been generated that shouldn't have been generated. The operation class. We'll learn about partial updates later on in the course, and this is related to that. It's already defined in the ASP.NET Core framework, so we don't need a generated version of that. So let's open the settings and add operation to the excluded types list. And let's click Generate Output again. And there we go, no more operation. Now let's add these to our project. Back to settings. Let's scroll all the way down. We click the three dots next to output path, and we navigate to our client project. On my machine, that's on C, Pluralsight Demo, Movies, movies.client. Let's add a new folder, Models. Let's double click that. And now let's name the file that's going to be generated. What about generated DTO models? Alright, let's save. And let's click Generate Files. That should be it. Now let's open Visual Studio and have a look at our Movies client. We're still running from when we started the API, so let's stop that. And there we go. We now have a Models folder, and contained in that Models folder are our DTO classes. And that's it. Now let's have a look at how we can tackle integration with HTTP client. What you see on screen is a very basic sample of using an HTTP client instance to fetch a list of movies, and afterwards use JSON.NET to deserialize the response into a list of movie DTOs. I'm sure this will look familiar to a lot of you, but if it doesn't, don't worry, all will become clear during the course. Before we're going to write actual code, it's important to understand what HTTP client is and how it works. In other words, what does this code do? We're working with HTTP, which is a request-response protocol between a client and a server. A client submits an HTTP request to the server, and the server returns a response to the client. It's used constantly in our daily lives. A good way to start is by looking at the web. A browser is a client that can send HTTP messages and capture responses. Let's open Chrome, and let's open its DevTools by pressing F12. And let's surf to a site. I'll use my own site as an example, but any site will do. On the Network tab, we can see a set of requests. Let's open one. The browser sent a GET request to kevindogs.com. It includes a set of headers in that request, the request headers. These define the operating parameters of an HTTP transaction. For example, by setting the accept header, the browser stated the format of the response it wants to accept from the server. And then the server responded with an HTTP response message. That too has its set of headers, the response headers. For example, content type tells the client what the type of content of the message body is, and from that the client can know how to parse that content. Let's click response. The response body in this case, well, that's the HTML of my homepage. Let's click headers again. The response also contains a status code, 200, and that states that the request was successfully handled. There's a variety of status codes that exists, and we will look into these later on in the course. We can, by the way, also use this browser to send requests to our API. Our API is up and running, so let's send a request to API/movies. Let's click that request. This made the browser send a GET request to our API. Our API returns a response message with a 200 OK status code and a list of movies in the response body. You can see that by clicking response or nicely formatted on the left. Yet, when we want to integrate with an API from code, we don't have a browser at our disposal. Well, theoretically we could fire one up in some cases, but that's clearly not a good practice. And that's where HTTP Client comes in. It's the go-to class for sending HTTP request messages and receiving HTTP response messages. Through HTTP Client, we can send the GET request to GetAPI/movies. That's the request message you see on screen, and we can catch the response. That's the response message you see on screen. But how does it do this? How does it handle sending these requests and receiving these responses? It does that through message handlers, implementations of the HTTP message handler class. Such a handler is an object that accepts an HTTP request message and returns an HTTP response message. How that happens is dependent on the implementation. Not all handlers have to actually send requests over the network. We could, for example, have a handler that does nothing more than manipulate one of the request headers. HTTP Client Handler is the default handler used by HTTP Client. And that one does actually send a request over the network and returns the response it gets from the server. Often though, a series of message handlers are chained together, resulting in a pipeline. A request is received by the first handler in the pipeline. That one potentially does some processing and passes on the request to the next handler. Eventually, a response is created and it travels back up the pipeline. This pattern is called the delegating handler pattern. The HTTP client handler is typically the last one in the chain, but any of the previous handlers can decide not to pass on the request to the next one. A good example is a caching handler, which inspects the request, checks if a previously stored response is available, and if it is, returns that response instead of passing through the request to the next handler. So that's the high-level overview of how HTTP client works. In the next module, we'll start using it.